Good morning, Year 5, and welcome to your Tuesday maths lesson. Could you please record in your maths book today's date and learning objective to recap equivalent fractions and underline them neatly with a ruler. Then record Flashback 4, write 1, 2, 3 and 4 down, and then have a go at the time. Pause the video and come back to me when you've finished. Let's have a look at the answers to the Flashback 4. Write a fraction equivalent to 1/2. You could have had 2 quarters because the top number, the numerator, is half the denominator. You could have 3/6 because the top number is half, the numerator is half the denominator. You could have 10/20ths because the top number is half the bottom number, and so on. So long as in your fraction the top number, the numerator, is half of the bottom number, the denominator, then you are correct. Number 2, multiply 168 by 5 is 840. Number 3, to work out the perimeter of the rectangle, you need to add up all the sides. So you will do 6, add 20, add 6, add 20, which is 52 millimeters, because that's the measurement. Number 4, write 500,000 in figures. It's 500,000. And on your time, it's gone past the 5 o'clock, but it's not yet at 6. And it's gone 40 minutes past. So it's 5:40 a.m. or p.m. For the morning, it will be 0540 hours in the 24-hour clock and 1740 in the 24-hour clock if it was in the evening. Let's move into today's learning. Today we're going to recap or recover equivalent fractions, which you will have done in Year 4. Let's have a look. Let's begin with some warm-up skills to help us. For this, I'd like you to apply your learning from last lesson. You might also want to refer back to your fraction wall to help you. I'd like you to think what symbol needs to go in between. Greater than, equal to, or less than. Pause the video and have a go. Let's have a look at your answers. So in the first one, we can see that a half is greater than 1/4 because 2 of these quarters would be the same as 1/2. In this one, on a half, think what we did in our Flashback 4. Can you see that 7 is half of 14? So this is the same as a half, or equal to. Here, 13 is half of 26. So here, 13 over 26 is half. So therefore, 13/26 is equivalent to 1/2. What about in this one? Is 15 half of 31? No. 15 is less than half of 31. So therefore, if I was thinking about it, 15 over 31 will be less than a half. Therefore, this one, which is a half, is greater than this one, which is less. If I was going to draw this on a number line, if I've got 3/5, that's got to be more or greater than having 2 of the same fifths. Let's learn today's learning and apply that knowledge. The word we're concerned with today is equivalent. Can you see a word in there that you're familiar with? Yes, equal sounds very much the same. It means that anything that you are looking at has the same value. It takes up the same amount of space. It would take up the same amount of space in a bar model, the same amount of space on a number line. This is 1/4. Let's recap what those parts mean. Here we have the denominator, and that tells us how many equal parts a whole one has been split into. The top number is called the numerator, and that tells us how many of those parts we're using, how many we've got. So out of 4 pieces altogether in the whole, we've got 1 of those pieces. Is this correct? No, because the parts are not equal. They need to be equal like this. Here we can show one of the pieces is shaded out of 4 altogether, so that's 1/4. Don't forget our learning from yesterday. It could be here, here, here. It could be anywhere so long as one is shaded. But usually we tend to shade the nearest one to the left. It helps us to do comparing. Let's have a look at 2/8. Now, for this purpose, my bar must be the same length. I cannot make it so that I colour in 8 squares and it ends up longer. So my bar must be exactly the same length, and I split this bar then into 8 pieces. I shade in how many? 2, like this. So if I'm going to compare 1/4 and 2/8, what do you notice? Let's slide it up to compare. You should see that 1/4 is equivalent to 2/8. It takes up the same amount of space within the bar. The bars are the same length, they've just been split into different amount of pieces, and 2/8 is the same as or equivalent to 1/4. Or 2/8 is equivalent to 1/4, 1/4 is equivalent to 2/8. Is 6/9 equivalent to 2/3? Let's have a look. What have I drawn here? Count the pieces. There are 9. How many are shaded? There are 8. There are 6, so we have 6/9. What about here? We've got 3 pieces and 2 are shaded, so we have 2/3. Is 6/9 equivalent to 2/3? Remember, the bars must be the same length. Slide it up and compare. Do they take up the same amount of space? Yes, they do. So 6/9 is equivalent to 2/3. 2/3 is equivalent to 6/9. They take up the same amount of space. Have a think. Which one of these is the odd one out? Let's build it to check. Here we have 4/9. Here we have 6/9. And here we have 4/6. Let's put one on top of the other so we can compare easier. I've written them at the sides so you can see which one they represent. What do you notice? Which ones are the same? Which one is different? Which one is the odd one out? You should notice that 6/9 and 4/6 stop at the same place because they are equivalent. And you should see that 4/9 is less than both of these. So 4/9 is the odd one out. Let's have a look. A fraction wall helps us, and remember, in the flip chart we're going to use this. You can come back to this at any point to help you in your learning today. So we can see the bar represents one whole one. A half and another half, that's 2 halves, or 2/2, is the same length as one whole one. And so on for each of the pieces down here. And you can see the fractions they represent down the side. Let's use this today to help us with our learning. Can you see I've gone 1/6 and I go to the end of it. I'm trying to find fractions that are equivalent to it. So I can see 1/7 is not, it stops before it. I can see that 1/5 is not, it goes past it. But if I draw my line down, I can see that, 2/12, 1/12, 2/12 stops at the same point on the fraction wall. So therefore, 1/6 is equal to or equivalent to 2/12. Let's have a look this time at 3/4. Can you see my 3/4? That's 1/4, 2/4, 3/4. So I go to this end at the end of the 3/4. And I'm going to see what I can find by going up or down that are equivalent to 3/4, that takes the same amount of space. Can you spot them? Let's have a look. Can't be fifths, not sixths, not sevenths. Aha, eighths. How many of them? 1, 2, 3, 4, 5, 6 eighths. Any more? No, no, no. Aha, how many twelfths? There are 9 twelfths up to there. So 3/4 is equivalent to 6 eighths is equivalent to 9 twelfths. Let's have a look at how it could help us if we wanted to find another fraction. What about 2/3? Well, here's 1/3 and there's 2/3. Can you apply the learning? What is equivalent to 2/3? Here's the end of 2/3. Have a think. Going up and down, what is equivalent? Can you find more than one? Let's see. Coming down. Aha! Count how many. 1, 2, 3, 4, 6 is equivalent to 2/3. Keep going down. Here, 6/9. So 6/9 is also equivalent to 2/3. Are there any more? Yes, you can extend the line down to here. Well, if that's 9/12, then this bit on this side must be 8/12. So 8/12 is also equivalent to all of these other fractions because they take up the same amount of space on the wall. Your turn to have a go at questions 1 to 4. Please lay your work out in your book and use this fraction wall at any point to help you. Lay it out like this. When you finish number 4, come back to me. Let's have a look at question 5 and a similar question. Always, sometimes, or never. True. This person says the greater the numerator, the number on the top, the greater the fraction. That means it's a bigger fraction overall. Is it always, sometimes, or never true? Well, we need to find examples to prove our thinking. Let's start with 1/7 and 4/7. Notice the denominator is the same, but the numerator, this one is greater. The greater the numerator, the greater the fraction. Is this true? Let's build it to prove it. Here I've split my line into 7 pieces. Here is 1/7. Underneath I draw an identical line, but this time I shade in 4 of the 7 pieces. This shows someone that I am proving that the greater the numerator, the greater the fraction when I compare 1/7 and 4/7. Is it always true though? Can I find one that doesn't work? So here I can see that the numerator on this side is greater. So therefore this side, 2/10, should be greater than this side, which is 1/3. Let's build it. Here I've got 1/3. My line for 2/10 has to be the same length, so it must stop here, like that. And I shade in 2 of the pieces. Now you should notice in this one that 2/10 clearly is less than that, so it does not prove this. Therefore, it is not always true, it's not never true, it's sometimes true, and I've proved it with 2 examples. Like that. I'd like you to have a go at question 5 on your worksheet, please, and stick it in to prove statements true, always, sometimes, or never, and give examples to prove it in your thinking. Red group, when you've done that, or anyone else who'd like to try the challenge, you have your challenges here, and for each one I've given you some sentence starters to help you begin your answers. Good luck with your learning today, and I look forward to seeing your answers. See you tomorrow.